I would like to thank the organizing committee for giving me a chance to present one of the ongoing efforts that Breeding Insight has been doing for the specialty crops and animals at USDA ARS. So my talk today is for leveraging mid-density genotyping for building microhaplotype databases. So the target for this is to build a resources that can be used for the public for genomic insights and public collaborations. So what is Breeding Insight? Breeding Insight is a USDA ARS funded initiative. We built in 2019, and our mission is to transform breeding by enabling the implementation and genomic insight and selection as part of routine breeding programs across all of USDA ARS. So what we are and what we're not, some people at the beginning think we are competitors. We're going to steal publications. We're going to steal their discoveries. So I want to mention that, so again, we are a USDA ARS funded initiative, and we are located at Cornell. There are about half of the Breeding Insight employees actually located across US, working remotely, and about half that work locally at Africa. And we are a service and technology transfer model, providing additional support to USDA specialty breeding programs. What we are doing is to connect and build resources for specialty crops and animal breeders. Again, we are a team made up of scientists and software developers. And as of today, we are providing direct support for 27 plant and animal species. Out of that, polyploid species is a big part of the species that we are providing support to. So this gives a new overview of the growth of Breeding Insight. So the idea came out in 2018 by Ed Barkler and Zhao at Cornell, and then got funded. And then in 2019, Breeding Insights started with 6 species and 10 programs from the ARS. And in 2021, this increased into 17 species. As you can see, it's a mix of plant and animal species, and from different ploidies to diploid to hexaploid, and then tetraploid, and then octoploid. And as of today, we are providing services to 57 species and 59 programs all across US. So what the ideal aspirational goal of Delta Breed, which is what we're trying to build as a with the science team and the development team, is to unite all the data and applications that are in use by our breeders and Breeding Insight. We do not want to reinvent wheels if there's already software or application out there. So by using the BRAPI, which is a language to allow different applications to talk interchangeably, to link all the available software or applications. So we use breeding databases for breeders to store like phenotypic and genotypic data, but genotypic data storage is still the ongoing effort for Breeding Insight. And then we provide breeders with phenotyping tools, moving from pen and pencil, paper and pencil to digital genotyping, including field book and Smartric. And we also provide genotyping efforts by we provide low density and mid density genotyping platforms, but we are not the unit that actually doing the genotyping, but we help build the panel and then outsource the genotyping, which the genotyping will be a focus of my talk. And then in the meanwhile that you have the genotyping data and large amount of phenotypic data, what we do, another effort is to build bioinformatics pipelines for connecting, do interpretation of this large amount of data. And in the meanwhile, we also develop like analytical pipelines for image analysis, and also for linking, like do all this kind of analysis and put them into a user interface that people don't have to know Perl, do not have to know Python or C++. They just have a website interface that they can run some of their analysis by themselves. I do want to mention that if you happen to go to the PAG in the next couple of days, Sean Yarns from Breeding Insight will present this platform called Delta Breed, updates and future on Friday. So I said my focus will be on the genotyping resources. So what Breeding Insights target is that to build accessible, reliable, fast, affordable, and repeatable genotyping platforms for breeders. So start from the 2019, what we have developed, our panels are listed here. And so some of them are generated, like the 2K group panel and the 3K and 5K DARTech panel for strawberry are built by collaborators. And then all the rest were developed by Breeding Insight. And as you can see that the majority of them are mid-density genotyping platforms comprising about 3,000 genomic loci. And this is the growth of the marker panel development over the past 3 years. So we want to make routine genotyping affordable for all the users, so that Breeding Insight has teamed up with DART. If it's the first time you heard DART, it's a diversity arrays technology company, and it is located in Australia. To provide breeders with affordable and high quality genotyping options, and also vendors with rapid turnaround time suitable for any genomics application, including linkage map construction and genomic selection. So at DART, there are mid-density targeted SNP genotyping, which is called DARTech, which is the focus of my later part of talk. And then they also do high-density GBS-like genotyping called DART-seq. So the DARTech platform is based on padlock technology. If you heard, it has another name called molecular inverse probe. So basically this method is a target genotyping method that is suitable for many hundreds to thousands of markers. And you can target SNPs or small indels. So the output from this technology is actually a amplicon sequences. Previously, it's 54 base pairs, and now it's 81 base pairs. So these amplicon sequences, we process them as microhaplotypes, and which is produced called missing allele discovery count from DART. And this is the microhaplotypes from the MEDC report. As you can see that this red is the target SNP. It's from the reference and alternative allele. And then, but in addition, what you get is some off-target SNPs. That now you have a different combination of this target and off-target SNPs that you can actually have more confidence when you do the genotype analysis. So how do we use the DARTech genotyping results? So we have successfully did many species. So first, the thing you can do is to use the genotype codes from both the target and off-target SNPs. So we have built several or many linkage maps. So Manoj will present the linkage map in Blueberry, and Alexander will do in Alfalfa, and Shufen tomorrow will show her work in Cranberry. We all build maps use this star tag. And Marcelo, with help with Marcelo, we also did that for sweet potato, but we're not going to talk about it during this workshop. So you can also do GWAS, genome prediction, QTL direct detection. But the other big part is that we can build microhaplotype databases for public use. So our vision for microhaplotype databases is that so we collect all the microhaplotypes by all the genotyping results from breeders from like across US or even like international breeders. So we compile all these haplotypes. As you can see, this is a multiple sequence alignment. You can see the comments, SNPs, and both target and off target. So that if you know that there are polymorphisms in a specific locus that were not present in your germplasm, but in some other germplasm, that you can contact and do collaboration and to improve your breeding process. And further, that this information will be linked to Delta breed, where you can see like, what's the genotype based on the microhaplotypes. So for building this microhaplotype database is that after we get the report from DART, it will talk with a microhapdb that hosted by Breeding Insight. And then like we do multiple sequence alignment for all the microhaplotypes for a specific locus. And then in the meanwhile, we have generate VCF that you can view the genotype on Delta breed. So just to give you an example is the database for alfalfa. So far that we genotyped 155 plates, about 12,000 samples of cultivated and wild Medicago species. And what we observe is, as you can see from the graph, is that the number of new haplotypes being added to the database is starting to asymptote and suggests that we have found most of the microhaplotypes in the breeding germplasm. So this is a PCA showing like all 12,000 samples. You can see the diversity of this. And so we want these resources to be benefit to all the public. So what we're thinking is that, we will operate it under the FAIR data model. And then this is the way to interpret or to talk with the database. And the data sharing model is like something will open to the public and some will limit it between collaborators, and some will be private to the breeders, so that anybody will feel safe to share the data to their own comfort level. Okay, with that, I would like to thank USDA, Cornell, Breeding Insight, and the USDA ARS alfalfa and forage genetics team, and tools for polyploidy. We use lots of the tools from this workshop. So we are a direct benefiter of this. Yeah, thank you so much.